Assalamu alaikum, dear viewers. Shoaib and Dayo is here with the lecture of the basic construction of the electrical machines. In today's lecture, we are going to discuss about the basic construction of the electrical machines, means the parts of the electrical machine, that what kind of the parts that are used to construct any electrical machine. In the previous videos, in the previous lecture series for electrical machine subject, we have discussed the electromechanical energy conversion process, that the conversion of mechanical energy into the electrical energy or vice versa with the help of any coupling media, which is the magnetic field. That was the electromechanical energy conversion process. Now, in today's lecture, we are going to discuss the basic construction of the electrical machines. Okay, any electrical machines has the two parts, stator and the rotor, and both are separated by the air gap. Now, what is the stator and the rotor? You can see the word from the stator is the static part, and the rotor is the part which is free to rotate. So that are called as the stator and the rotor respectively. Both these stator and the rotor are separated by the air gap. Now the function of the air gap is to magnetically couple both coils, magnetically link both coils. In between there is no any electrical connection between these two parts, stator and the rotor. Okay, stator comprises of the number of the conductors and rotor is also comprises of the number of the conductors. Let's discuss the first part, stator part. This part of the electrical machine is stationary and normally is the outer frame of the electrical machine. Stator is the static part of the electrical machine. Okay, as you can see from the diagram, there are the two machines over here, salient pole and the non-salient pole. Later on we will discuss now. But the outer frame, which is the static part, so that will be called as like your yoke, and inside there are the two parts. Inside the frame there are the two parts, stator and the rotor. The stator also comprises of the windings, either it is a field winding or the armature winding. It depends upon the construction of the electrical machines or the type of the electrical machine, whether it is salient pole or the non-salient pole electrical machine. Second one is the rotor. This part of the electrical machine is free to rotate, and it is the inner part of the electrical machine. The rotor is the inner part, as you can see from the diagram. This is the stator and this is the rotor. Rotor is the inner part of the electrical machine and it is free to rotate. Okay, it is in the rotational part of the electrical machine. The function of the one member, stator or the rotor, is to provide the magnetic field, is called as the field structure. It depends upon the types of the electrical machine, whether you are placing the field winding on the stator part or whether you are placing the field winding on the rotor part. It depends upon the types of the electrical machine, that which type of the electrical machine that you are using. Okay, either it is salient pole or non-salient pole. Now the function of the one member, either it is placed on the stator or the rotor, is to provide the magnetic field, which is called as a field structure. The function of the field structure is that to create the magnetic field, magnetism in the winding. That winding are called as the field winding. In the field winding, the magnetism has been produced. There are the two types of the magnets, the permanent magnets and the soft magnets. The permanent magnets are the gifted from the Allah, and that are like permanent magnets. They have the permanently magnetic properties. But the electromagnets are those magnets, like take an example of the coil or the solenoid, and we are energizing that coil with the help of electrical supply. Then it has the your the function of the magnet, and it will be called as the electromagnet. Now, the field structure is that in which the creation of the magnetic flux is to be takes place, that is called as the field structure. Either it can be placed on the stator or on the rotor, depends upon the type of the machine. Clear? Second, the function of the other member is called the armature, and is to provide the assembly of the conductors of the armature winding, in which EMF is induced in them due to the magnetic flux linking with the coil, so that EMF will induce in them according to the Faraday's law of the electromagnetic induction. Whenever a flux is linking with the coil, it changes and EMF is induced in them. So from this line we have cleared that there are the two members, the stator and the rotor. Stator is the outer part, rotor is the inner part, which is free to rotate. Either you are placing the field winding on the rotor side or the stator side. The main purpose of the field winding is used for the creation of the magnetic flux, and other member is called as the armature. And the function of the armature winding, if you are using the group of the conductors, then that will be called as the armature winding. The function of the armature winding, that in which the EMF is induced in them because of the lines of the cuts of the flux from the first member, in which the magnetism has been produced. So according to the Faraday's law of electromagnetic induction, whenever a flux is linking with the coil, it changes and EMF is induced in the coil. So this is the function of the first member, field structure, and function of the second member, armature member or the armature winding. Now, second point. Both stator and rotor are made up of the ferromagnetic materials, so that reluctance of each is negligible as the comparison with that the reluctance of the air gap. Already I have discussed that the both members are separated by some air gap. Okay. Now air gap is links the magnetically linking, provides the magnetically linkage between the two members, the stator and the rotor. For example, if you are energizing the stator, like your field winding is placed on the stator side, in the case of the DC machine, the DC supply is to provide to magnetize the field winding, and already the armature winding is to be rotated by the help of the prime mover. The lines of the cuts of the conductor within the conductor is to be takes place according to the Faraday's law of electromagnetic induction, d phi over t. Whenever a flux linking with the coil is changes and EMF is induced in the coil because of the rotational member of which is called as armature winding. Now, ferromagnetic materials. Ferromagnetic materials are such type of the electrical material or the magnetic materials which are strongly attracted by the magnets. Generally, the core of the electrical machines are designed on the basis of that ferromagnetic materials, because they have the strong magnetic attraction towards the magnets. And reluctance of the each is negligible. Already the reluctance is the opposition offered by the magnetic circuit to the flow of the magnetism, to the flow of the magnetic lines of the forces, to the flow of the magnetic flux, that is called as the reluctance. So according to the according to the magnetic flux formula, phi, which is the magnetic flux, okay, it can be easily calculated with the MMF, magnetomotive force, divided by your S, which is called as the reluctance. From this expression, if you are decreasing the reluctance in the magnetic circuit, the flux will be maximum. If the flux will be maximum, the lines of the cuts of the flux is maximum. Obviously, EMF is induced in the conductors will be the maximum, because here the opposition is negligible. Obviously, the permeance will be higher. If the permeance in the magnetic circuit will be high, it permits the flow of the magnetic lines of the forces within the conductors, so EMF is induced in them. So this is the main purpose of the magnetic flux when according to the Faraday's law of electromagnetic induction. So all MMFs of the magnetic circuits of the electrical machines required to set up the flux in the air gap. If the reluctance is negligible, the material, your stator and the rotor both are both magnetic materials are made up of the ferromagnetic materials. reluctance is negligible. Obviously, the MMF will set a magnetomotive force is set up, which tends to move the magnetic lines of the forces. Okay, passes through the air gap, and that will be the function of the MMF in the magnetic circuits. Conductors are placed in the stator slots, and also the conductors are placed in the rotor slots of the electrical machine. A stator comprises of the slots in which the windings is embedded in the slots of the machine, and already again the rotor is comprised of the slots in which the windings to be embedded in the slots of that rotor winding. The conductors which are placed in the slots of the stator and the rotor are interconnected to form the windings. So if we have the slots and we are going to connect the conductor from one slot to another slot, it makes in the form of the windings. So the windings are going to be produced, and we have to create this magnetic poles that are called the electromagnets. The windings in which voltage is induced in them, that is called as armature winding. Already I have discussed that. The function of the field structure is used for the creation of the magnetic flux in the field winding, and also the function of the other member, which is called as the armature. If we have a assembly of the group of the conductors in the armature, that obviously it will be called the armature winding, in which EMF is induced in them. In the case of your generator action, and in the case of the motor action, the back EMF is produced in them, and in the case of the generator action, the generated EMF is induced in them. Okay, so this was the theoretically idea of the two members, the stator and the rotor. Now coming towards the types of the poles construction of any electrical machine. There are the two types of the field pole construction. Number one is the salient pole construction. Second one is the non-salient pole construction. In the salient pole construction of the machine, the field structure or the field winding is placed on the stator side, and the armature winding is placed on the rotor side. So this is the main example of the DC machines. All the DC machines, either DC generators and the DC motors, uses the such type of the construction which is called as a salient pole construction. In the salient pole construction, the stator is comprises of the field structure, field windings, and the field winding is to be excited from the DC supply to produce the magnetism effect, to produce as an electromagnet, or to produce the magnetism effect in the field windings. And second is that your rotor. The rotor comprises of assembly of the group of the armature conductors, and in the case of the DC generator action, already the field winding is energized from the DC supply, and your armature winding is placed on the rotor side, and your armature winding, your rotor side of your DC generator is moved from the external prime mover, then according to the Faraday's law of electromagnetic induction. Whenever a lines of the cuts of the flux is to be takes place within the conductor, from that field structure, from the first member, what happened? The EMF is induced in the armature winding, so that will be called as the generator action, DC generator action. Okay. And in the case of the DC motor action, in the armature is going to be supplied from the DC supply, so in which the EMF is induced there, and then that is called as the back EMF or the counter EMF. Okay. Second is the non-salient pole construction. In the non-salient pole construction, the rotor is comprises of the field winding, and your stator is comprises of the armature winding. Already a function of the armature winding in which the EMF is induced in them, and the field winding is to produce the magnetism. I repeat all these things because you have to clear the concept regarding the armature winding and the field winding. The purpose of the field winding is to create the magnet in which the magnetism has been established, creation of the magnetic flux over there, and means that function is like your electromagnets. Okay, and also the armature winding is that in which the EMF is induced in them. This type of the construction is used in the AC machine, like your synchronous generators, which are used in our power plants to produce the bulk amount of the electrical power. They are used for the production of the electrical power in the power plants. Your power alternators, these three-phase synchronous generator, uses such type of the non-salient pole construction. The field winding is to be provided on the DC on the rotor side, and our DC supply is to be given to that field winding. And the armature winding are the stationary placed on the stator part of the alternators, and in which we are getting the induced EMFs, in which we are getting the three-phase voltages from the output of the alternators. And this rotor member in which the field winding has been connected, it's going to be rotated with the help of the external prime mover, that may be the steam turbine or the gas turbine. It depends upon the type of the power plants. And when it is rotated with the help of the prime mover, the lines of the cuts of the flux is to be takes place, because already the rotor is energized from the DC supply. And magnetism effect has been established in the rotor windings. Then what happened according to the Faraday's law of electromagnetic induction? Again, whenever a flux is linking with the coil, it changes the lines of the cuts of the flux, and the rotor sides are to be takes place. What happened? EMF is induced, and then this is the alternator action in this synchronous machines, or like in the power plants that we are using for the bulk amount of the production of the electrical power over there. So this was the basic construction of the electrical machine, and I hope that you have understood today's lecture regarding the basic construction of electrical machine. Any electrical machine has the two members, rotor and the stator. The rotor, maybe the field structure is to be placed on the stator side or on the rotor side. It depends upon the types of the electrical machine. So there are the two members, the field structure and the armature structure. Okay, armature winding. The field winding, the purpose of the field winding is to use for the creation of the magnetic flux as always. Magnetism effect has been produced always in the field structure, but the main second member is your armature winding, in which the voltage is induced in them. So this was the summarized theoretically concept regarding this lecture. I hope that you have understood today's lecture, and at the last, please don't forget to subscribe my YouTube channel Shoaib for more informative videos related to the electrical engineering area. Thank you.